Before you do the review questions, I just wanted to go over a few things on the formulas and how to interpret graphs for motion. So let's start off with uniform motion. Uniform motion means that velocity is constant. And when velocity is constant, we can find our distance traveled, which is just delta D. And if we know our distance, we can take that distance divided by time to find speed. So this VAV is the average speed or the speed. I'm just going to shorten it and put speed. Both of these are not vectors, so that means they don't have direction. But we are going to focus on the vectors and look at position and how the position changes with time. If velocity is constant, then the amount it's moving every second is going to be the same, and we see a straight line. This object is moving forward at a constant velocity. And we can find out what that velocity is if we take the slope. So if we have a position and time graph and we want to find the velocity, we can take the slope. So a steeper line with a higher slope would be going faster, and a less steep line with a lower slope would be going slower. We can, just as a review, to find slope, we would take 2 points off the line, and then we would take the y values and subtract them. So y2 minus y1, and divide it by x2 minus x1. So we can find the velocity just from the graph if we can find 2 points on that graph and find the slope. So whenever we see this graph, straight line graph, we know that this is a constant velocity and it's going in the positive direction because our slope is rising and the object is going away from where it started. Constant velocity, and it's positive. So if I was going to plot a velocity, it's going to have the same velocity at every single time, and it's going to be positive. So that should be a flat horizontal line. My pen isn't 100%. And that's what my velocity time graph would look like. So just as a reminder, velocity has the arrow because it is a vector. And change in position is also called displacement, which is also a vector, so it should have a direction. So these ones are vectors. In my second example here, the position is going down, so it is actually moving backwards. So it's constant velocity, but it will be going backwards or negative, have a negative velocity. So it's going backwards. And when it's positive, it's going forwards. So that's a summary of constant velocity, which is also called uniform motion. Let's take a look at non-uniform motion, where there is acceleration. Acceleration just means that the velocity is changing. So the first thing that we did when we looked at that is we solved problems where we had a change in velocity and a change in time, and we could see what the acceleration is. So when you are doing these problems, I'm just going to add to this formula that we will have to take the final velocity minus the initial velocity and make sure you look out for if an object's at rest, then the velocity is 0, and then divide it by the time that it takes for that change in velocity. On a graph, what we see is the slope starts very low if you have an object speeding up. So here we have it rising very slowly, and then the slope gets steeper and steeper and steeper as it goes faster. So this first example of this graph is an object speeding up. So we know we have our velocity, that it's starting low and rising. In the second example, it's rising really quickly and then it slows down and doesn't rise as much. So the slope is decreasing. So this one is slowing down. It's not going as fast as time goes by. So this one's slowing down. So it's going to start with a high velocity and decrease. And that should be linear. So we should know the graphs for when velocity is changing and there's acceleration, for speeding up and slowing down. And we should also know how to use this acceleration formula if we know our final velocity and initial velocity and time. The last thing that we want to do is, if we look at the velocity time graphs, we have a linear graph because the velocity is changing. So here, when it's speeding up, the acceleration tells us how much the velocity is changing every single second. So if I take the slope of an acceleration or velocity time graph, that's telling me how much my velocity is changing, the slope, how much it's changing each second. So that is actually my acceleration. Don't confuse this with the slope of a position time graph. But if I take the slope of a velocity time graph, it would tell me my acceleration. Because it's telling me how much that velocity is changing every second. And acceleration is always meters per second squared. If I have a rising slope, that means every second my velocity is going up. Say it's going up by 2 meters every second. So I'd start at 0. The next second I'd be going 2 meters per second. The next second I'd be going 4 meters per second. The next second I'd be going 6 meters per second. That is positive if my velocity is rising. But if my velocity is decreasing, then we have a negative acceleration, because I started it with a high velocity and then 1 second later, say I started at 10, and then 1 second later I'd be going 8 if I had -2. Acceleration of -2 meters per second squared. So say I started at 10 as my starting velocity, and then 1 second later it would be going 8 if this was -2 meters per second, because the acceleration is taking away, the velocity is decreasing or getting smaller every second. We have a negative acceleration. And we can see also, if we did the calculation for slope, when it goes down, we would end up with a negative as well. So that is a summary of all of our formulas and graphing. One more thing that I just wanted to quickly go over is converting units. To convert units, just a quick reminder. If we're going from minutes to seconds, there are 60 seconds in every minute, so we have to multiply however many minutes we have by 60. And then if we're going between kilometers and meters, kilometers is 1 kilometer is 1,000 times bigger than a meter. So if we know how many meters we have and we want to go to kilometers, we actually have to have less of them because that's a very big unit. So we divide by 1,000. But then if we go from kilometers to meters, which is a smaller unit, we have to have more of them because they're shorter to get the same distance. So we multiply by 1,000. So this is 2 ways that you will often convert units in this unit.